Good morning, I am Dr. Kanchan Wag, Assistant Professor at Cummins College of Engineering for Women, Nagpur. Today I would like to cover the introduction part of optical communication. Now, initially a question arises, what is communication? The term communication is defined as the transfer of information from one point to another point. In communication, what happened? We transfer some information or some data from one point to another point. The starting point is called as source and the end point is called as destination. Now for the information to be transferred over a distance, we need a communication system. Now a communication system that uses light as the carrier of information from a source to a destination through a guided fiber cable which is made up of glass or plastic is called an optical fiber communication system. It means in optical fiber communication system, we reused optical fiber cable which is made up of glass or plastic as a communication channel. It acts as a carrier. Light acts as a carrier and light passes through the optical fiber. So light acts as a carrier. Now the information carrying capacity of a communication system is directly proportional to its bandwidth. It means that higher the bandwidth, greater is the information carrying capacity. In optical fiber communication system, the bandwidth is higher so that it carries more information. Now, light frequencies used in fiber optical systems are between 10 to the power 4 and 4 into 10 to the power 14 Hertz. As a result, they have higher information carrying capacity. Now, fibers have an extremely low loss of about 0.2 dB per kilometer. Means fibers are having a very low loss, that is 0.5 dB per kilometer. Means after the transmission of means 1 kilometer, the loss will be 0.2 dB or 0.5% of power loss over a distance of 1 kilometer. Means after the travel of 1 kilometer, the loss is 0.5% only. Now this loss is very less as compared to the other conventional communication systems. Now because of high information carrying capacity and low attenuation, nowadays fibers are finding a wide application in telecommunication, local area networks, sensors, computer networks, etc. The carrier frequencies used in conventional systems had the limitations in handling the volume and rate of data transmission. The greater the carrier frequency, larger the available bandwidth and information carrying capacity. As we know that as the bandwidth is high, information carrying capacity is high, and for the bandwidth to be higher, carrier frequency should be a greater. Then we'll see the generation one by one, the generation of optical communication system. First generation system. The first generation of light wave systems uses gallium arsenide semiconductor laser and operating region was near 0.8 micrometer. Here gallium arsenide semiconductor is used as a laser in first generation system and operating region is about 0.8 micrometer. Other specification of first generation are bit rate. Bit rate is 45 Mbps and repeater spacing is 10 km. Means after every 10 km we require a repeaters there. Now let us talk about the second generation system. The specifications of second generation system are bit rate is 100 Mbps, repeater spacing is 50 km. After every 50 km we require a repeater and wavelength is 1.3 micrometer. Now let us see third generation system. Now the specification of third generation systems are bit rate is 10 gigabit per second. It is much higher than the first and second generation and repeater spacing is 100 km. As we know that in first generation system the repeater spacing is 10 km, in second generation it is 50 km and in third generation it is 100 km. It is much higher than first and second generation. and the wavelength is 1.55 micrometer. The fourth generation system. In fourth generation system, the bit rate is 10 terabyte per second. It is much higher than your third generation system. Repeater spacing is 10,000 kilometer. After 10,000 kilometer, we require a repeater. And here in fourth generation system, wavelength division multiplexing technique is used, and the wavelength is 1.62 micrometer. Now we have seen the first generation, second, third and fourth. Let us talk about the fifth generation system. In fifth generation system, the bit rate is 40 to 160 terabyte per second, and the repeater spacing is 35,000 kilometer. It is very high than your previous generation systems, and wavelength is 1.5 micrometer. Now in fifth generation system, Raman amplification techniques are used. Now we will see the need of optical fiber communication. Optical fiber communication system has emerged as the most important communication system compared to your traditional or conventional system because of the following requirements. Now we will see the requirements. Transmission loss. In long haul transmission system, there is a need of low loss transmission medium. Compact system, there is a need of compact and least weight transmitter and receiver. Long span, there is a need of increased span of transmission, and because of all these characteristics or all these requirements, we need a optical fiber communication. Now we will see the comparison of optical fiber communication with traditional communication system. Advantages, we will see the advantages first. These are the parameters. We are comparing optical fiber communication system with a conventional communication system. Depends on these parameters. Then we will see the parameters one by one. Bandwidth. In fiber optic communication, the bandwidth is in terahertz. In copper wire communication or conventional communication system, it is in megahertz. Distance traveled is long in fiber optic communication, and in traditional communication system it is short. EM interference. EM interference is electromagnetic interference. It is optical fiber communication system is immune to EM interference, and this traditional communication system is not immune to your EM interference. Size of circuit. Size of circuit is very less, and in traditional communication system it is bit bigger than your optical fiber system. Weight is very less, here weight is more. And losses, as we know that losses in optical fiber communication system is 1 dB per kilometer, and here it is 10 dB per kilometer. It is 10 times more than your optical fiber communication system. Now every system is having advantages as well as disadvantages. Now we will see the disadvantages of optical fiber communication system with the traditional communication system. And these are the three parameters. Fragility means delicate. Fragile means delicate. For glass fiber it is fragile. Copper is flexible. Installation. With splicing of fiber installation, it is little difficult, and here it is very easy to install. Cost is very high in fiber optic communication system, and in traditional communication system the cost is very less, as we used copper wire there, and copper wire is cheaper as compared to your optical fiber. Then in next lecture we will see the block diagram and working of fiber optic communication. Thank you.